So now when we're looking at statistics, we're looking more towards data types and the type of data that you might be seeing and how to sample for it and all of that. So first, some basic ideas of basic definitions, I should say. So when we're talking about data, we usually gather data from a population, all right? We gather data from a population by taking a sample from this population, okay? So for example, like let's say we have all right, we have like 5 people in a household. All right, we have 5 people in a household, and we want to take a sample size. So this is the population. So our population in this case is equal to 5 people. All right, actually, let's make it 10 people, just so that we have a larger number or a larger size population, because usually the population size is going to be, it can be either a finite number like 10 people or an infinite number if we're talking about something else. But in this case, let's say we have a population size of 10 people. And we would like to gather data about these people. All right, we will take a sample from these people. For example, we're going to select this person and this person. Like, let's say we want a sample of 2. All right, so a sample of 2 means we're going to select 2 random people using different selection methods. And then we will gather the information, for example, such as height or weight or age or whatever else we might want, depending on the type of data we want, the type of data we're trying to analyze. This is basically the whole uh, a simplified version of what you are collecting when you're collecting data. You're going to be taking a sample, in this case of a sample size of 2, from a population, in this case where we have a population of 10 people. All right. The data can be one type of data or one singular data or multiple data, like multiple points of data. And the way you can gather this data as well, there are a lot of different ways of gathering it and a lot of sources. So when we're talking about sources of data, we have 2 main sources, all right? The first one is usually called a primary source of data. To get a primary source of data, that means you yourself are directly involved in gathering the data yourself. Like, for example, you're going out, all right, and you're doing experiments to find out the values or the actual numbers, or you're conducting interviews. All right, you personally, as in you, the person that is analyzing the data, you are trying to collect this data directly from the population or from the sample, or like if you're giving out surveys, okay, or any other way, interviews, phone calls, actually just visually looking at the data or whatever. So this is called a primary source of data if you're gathering it yourself. Another type of data, or the second type, I should say, is secondary source. The source of data, I should say, actually. A secondary source is basically, you can think of it as referencing someone's data. يعني قاعدين تروحون تستخدمون شغل غيركم. Okay? So you're going to look at research reports by other people. So research from others. Or you can look at books from other people, like books that has been written by people, or journals, or even other people's surveys, like a survey that has already been conducted beforehand by someone else. All of this is types of data that the types of sources that you can have your data from. So the first one is a primary source of data, which you are involved in getting it yourself. And the second source is a secondary by referencing some other thing, by going and finding someone else's work and trying to do it. And obviously, each has their own advantages and disadvantages. Logically speaking, advantages of a primary source is that it will be much more accurate because you know what you want to get. But a disadvantage would be it takes too much time because you have to go out in the field and it might cost you a lot. And the opposite is in the case of secondary, because it's not going to cost you too much because you already don't have to put in the money to gather resources and data because someone has already done it for you. But sometimes the data you specifically want is not accurate or not detailed enough, or it can be out of date and all of that. So these are when it comes to finding sources for your data or your data, What about how to actually, like, the types of data you have? So what kind of data do we have? We have two main types of data. All right. The two types of data is, the first one being quantitative data. Quantitative, when you look at the number quantitative, you think of quantity as in numbers, right? So it's something that is related to a numerical value. So this data is basically data that is either counted or measured, all right? And it can be something like temperature or height or distance or weight or whatever. So it's a data that is represented as a number, okay? And there are two subcategories to quantitative data, okay? The first category being that it is a discrete value. If you remember from previously, we talked about discrete and continuous variables. So it can be a discrete value. A discrete value basically meaning that it is a value that you can count, all right? So this is countable, such as number of teachers, or you could say t-shirt size, or money. Actually, money is a type of continuous data, and I'll talk about that later. Or you can say a number of bricks, right, for building. These are all discrete values because these are all whole numbers, actual numbers that you can count. The other part, the other subcategory, all right, these are both quantitative, is continuous. Continuous data, meaning that it is, or continuous variables, are things that are measured usually. All right. So values that, you cannot just count them 1, 2, 3. You actually have to use a sort of measurement such as height, weight, age as well, because age is always changing. It's continuous. There isn't a specific exact number for someone's age. We usually use it in years, but if you go all the way to milliseconds, it will keep continuously changing. So this is the two types of quantitative data that you can have, which is basically when it comes to numbers. So it comes down to either counting them or measuring them. All right. The second type data is qualitative data. So qualitative data. All right. What is qualitative data? These are things that are usually like opinions or things that you can describe about something without the use of numbers, basically. So, okay, so you can think of it as the quality of things. All right. So you can think of it as the quality of the thing. For example, you could say the color of something, you could say it's black or orange or green. You could say uh, healthy foods, all right? For example, you could say that this is a healthy type of food, or that's not a non-healthy type of food, all right? Yeah, and there isn't a numeric value to represent it. Or, for example, another thing is language. You can say the language they are speaking, or um, the language that is being taught, or whatever. Yani, something that basically you do not use a number to identify. It is a description about it, all right? So it's a descriptive feature. So it's something that you can describe it without the use of numbers. It is just some property of whatever you're trying to gather data from. So these are the two types of data. The first one is quantitative data, which is depending on numbers and numerical values, and qualitative data, which is dependent on the shape, shape, color, um, type of material or whatever, or language, and all of that. These are the main ways of the main like types of data that you will always be using, all right? Or the two only data types that you would be using when you're gathering samples, depending on your population and depending on what you're trying to achieve. For example, like if you're trying to ask for someone's nationality, all right, this is a qualitative data, all right, because he's either from Bahrain, India, England, USA. This is something that describes. But if you're talking about something such as the number, as soon as you see number of, um, I don't know, the number of coins they have, This is quantitative because it has something to do with numbering, with values, with measuring or counting. All right. So it depends on the type of data that you want, and it depends on the type of surveys or interviews that you are doing, with whether you're trying to gather qualitative mostly or quantitative, depending on the analysis that you want to do. These are just general ideas, like just a little bit of theory of wording, of naming. Now let's talk about how to collect data. So the data collection. How is data usually collected? All right. There are a lot of different ways of gathering data. All right. The main one I kept on saying is usually through interviews. Interviews. All right. So when you interview someone, you're trying to gather information directly from that person. You will ask a series of questions. All right. So you're going to be asking questions, and they'll be giving you direct answers about the questions, whether it's qualitative or quantitative data. But it also has its advantages and disadvantages. Obviously, it takes a lot of time. It could require a lot of resources, and it also depends on the communication level of the interviewer himself and all of that. So, a second type of data collection is focus groups. What are focus groups? Focus groups is when you are gathering a number of people, like 10 people, 20 people. You're grabbing a group of people basically, and you ask them all a certain question and you get an answer from them all right? So you could be, again, it's going to be asking multiple people questions. So it's asking a group of people questions. Okay? This is what it basically is with focus group. So it's like an interview, but with more than one person. All right. And the idea of this is it's usually you get a better population, you have a larger population or a larger sample, I should say. So you can get more better opinions or more better facts from a lot of people as well. However, this can be a very tedious job. It's difficult to control sometimes, difficult to analyze or understand or interpret because of a lot of different backgrounds of people. So it also has its advantages and disadvantages. The third type is using calls, all right? Or you could say online meetings. Okay. Back in the day, it used to be mostly phone calls by calling specific people from a specific group, and those group of people, like you would call one by one, and you will get their ideas about everything. Or nowadays, it's mostly done through online meetings, or like as right now we are in a Teams meeting, or a bit like 10 years ago, it used to be Skype and all of that, where you would be able to gather information by asking people over, online, same as an interview, but it's being done online. The issue with this is sometimes the meeting can be very difficult because you connection issues, or you can have a difficulty communicating properly with them because you cannot read their body language. There's no face-to-face interaction and all of that. So it has its disadvantages as well. And the most important method is using questionnaires. Questionnaires are basically forms, right? These are basically forms with questions on them. With questions on them. Sometimes you can look at them as surveys. Okay. So questionnaires are just a form of survey, all right? Or surveys, I should say, is a form of using questionnaires to get the type of values or the type of data that you want based on questions that you can distribute through either online or by paper. Most of the time it's online using Microsoft Forms or Google Forms as well, or whatever website you'd like to use. And you have specific types of questions here. There are two types of main questions that this is split into. There's something called the open-ended question. Open-ended question. Open-ended meaning that they are free to respond with anything they want. So they are free to answer in any way. So for example, you would say, give me an idea about what you think is going on in Bahrain Polytechnic. This would be a type of open-ended question because there isn't a limit on what their answers should be. They can answer freely in any form they want. The other type is closed-ended questions. All right. These are questions that have a limited answer. So there is a specific answer that they can answer that is usually given through different methods, so limited answers. In other words, this basically means the person that is doing this questionnaire, he has to select a choice, whether true or false, or whether it is like 1, 2, or 3, or multiple choice question, or there's a scale. So as I said earlier, this is split into 3 parts. It's called yes or no questions. This is called dichotomous questions. Yes or no. This is also known as dichotomous questions. Then there is multiple choice, MCQs. All right. And then there is scales. Scales meaning saying rate this from 1 to 10, for example. All right, like rating scale. So you say based on your experience with this product or whatever, rate it from 1 to 10. Okay, and these are your most common types of questions that could be asked during questionnaires. This is kind of important because later on when you go into degree, if you have English, you're actually going to be having to do or prepare a survey from your side, and there you're going to have to be using open-ended questions and closed-ended questions, each of these, and you should be able to understand how to ask a question and what type of questions to ask and all of that. So you should know that you should involve some yes and no questions, some MCQ questions, and some scales so that you can get a larger variety of data while not making the person that is doing the interview or the questionnaire or the survey without him not having the morale to continue. You don't want it to be long questions. All right. I don't want to go too much into detail about this. This is just the general information that you guys need to know about when it comes to collecting data in your case. Now, the most important part about all of this, actually sampling the data that you have collected. All right. So when you have collected all this data, whether it was through interviews, through focus groups, through questionnaires, whichever method, now you need to know how you can gather a specific sample from your population. All right. So if we're going to look at this very quickly, this is what a population usually looks like. Oops, over here. So this is your population, all right? You have a number of different people, okay, with different opinions, with different backgrounds, and you're going to be selecting some of these people, as you can see here. They have selected these 3, 4, 5 people, and this is now their sample size. So their sample size here is, so the population is a large number, all right? I'm not going to count through all of these, but they took a sample size of 5 people only. The idea here is to take a sample without being biased, all right? So you're trying to be unbiased. What does this mean? So when you say there is a bias, that means not fairly. You can think of it that way. So you are selecting based on a specific reason behind it. يعني مثلا, all right? I'm selecting all the blue people. They're all from the same background because they're, for example, my friends. You're not going to get a proper sample size. Because they're all going to have maybe the same thought process. They all agree on the same points. So you're not going to get actual values or actual data. So there are methods of sampling. All right. The first method of sampling is something called SRS. All right. The SRS sampling method, or this is simply known as simple random sampling. The easiest way to explain it is using this picture. Okay. So simple random sampling. What does that mean? This means that you have a population here defined, all right? You have this population over here, okay? You select which population you want. For example, let's say the population of Bahrain, the old people in Bahrain, for example, the people of age 60 and above in Bahrain, that is your total population. You will have to decide a sample size, right? So we say people, so for example, here people over the age of 60, all right, in Bahrain. Then you say you want to have a sample size of 100 people sample. All right. So you only want to look at 100 people from all the people that are above 60. Obviously, there are thousands, if not hundreds of thousands of people that are above the age of 60 in Bahrain. So we just want 100 people from that entire sample because we cannot analyze the entire population all at the same time. Then after that, you're going to randomly select it through either a website or a قرعة يعني انزين, or a raffle kind of thing, where you are gonna number your people. So you're gonna say this is number one. يعني you say you got a million. For example, let's say we got a million people. You're gonna number them from 1, 2, 3, 4, 5. Yani this is the first person you interviewed all the way to 1 million. Okay? Then you will put all these numbers in a hat, for example, and then you will shuffle them, or you're gonna put it online through a calculator or through a random number generator, and it's gonna give you random numbers. So let's say it's gonna give you 57, 68, 95, 100,001, and all of these. This is the number of people that you are supposed to choose for your sample size. Once you select all these numbers, then you're gonna take the data from here. So this is basically what is known as simple random sampling. This is very rarely used because you cannot necessarily get very accurate data, because you don't know if the random generator is going to select all the people, for example, from one specific area or from a specific age group like 60 to 65 only, not people above 65. So it's not really an efficient way of sampling. Another method of sampling is known as systematic sampling. This method is a bit more efficient than the previous method, all right? This one is basically, let's say, if we look at this population with this sample size that we want, all right? So here we have a population of 12 people, okay? Randomly selected, 12 people. And we want a sample size of 4 people, okay? So we have 12 people and we want to select 4 people out of it. How do we do this? So we look at our population and we divide it by our sample size. So it's going to be equal to 12 divided by 4, which is simply 3. Then we are going to take a sample from every third person in our list. Okay, so we can start at any point. The starting point here is going to be randomized. All right, so this is a random starting point between 1 and 3. Okay, between 1, which is the very first person, and 3, which is our sample, or every third sample, which is our systematic sampling. So here, through a number generator, we got 2 to be our first number. Then we're going to go 1, 2 to the third person from there, so it's going to be 5. Then we're going to go 1, 2, again, 3 more people, so it's going to be 8. Then we're going to go 1, 2, 3 more people again, and it's going to be 11. And that's it, because we got our 4 random people from the population as our sample size that we can gather our data from. All right, this is known as systematic sampling. So you'll define your population, define your sample space, or sample size, I should say, and then you're going to use a random generator to identify where you're going to start, obviously between 1 and 3, which is your sample size, or the system between each one, the what do they call this? يعني the gap between each sample that you're going to take. And then from there, you're going to add 3 to the first one, which will become 5, and then add 3 to the next one, and add 3 until you reach the end of your population, and you will select those for your sample. The last one, which is the most commonly used, all right? The last one is known as the stratified random sampling. Okay, this is most oftenly used in a lot of things, especially when it comes to population of the census data. So census data, this is basically the data about a population, about a country's actual population, the number of people living in a country, right? They call that the census data. Okay, so stratified random sampling is mostly used for census, and it's the most commonly used. So to show you how this is actually done, so we have a population here, all right? This population is split into subgroups called stratums, all right? So as you see, we have 4 stratums here. These are known also as subgroups, okay, if you want to know, or the group, the plural form is strata. So these groups are split into subgroups depending on, for example, either age or location, where they're specifically from, like the city they're from, or nationality of the of where they're from, basically, and all of that. And you will split them depending on that. So people of the same age group, you're going to put them all together. People of the same location, you're going to put them all together. People of the same, or something like that, yeah. With depending on which type of stratum you want to use, depending on the type of analysis you want to do. Once you define all of this, okay, so in here, in this example, we have 40 is our population, okay? Our strata here, if you notice, each strata has a specific number of people, and when you add all of these up, they have to be equal to your total population. All right? So here, if you notice, stratum 1, if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So S1, we have 10. All right? ST1, we have 10. ST2, we have 12. ST3, we have 8. And then ST4, we have 10 again. If you add up all these numbers, you notice that if you add all of these, they're going to give you 40. Okay? So now, how do we use this method to find our sample size or our sample data? It depends, first of all, on the sample size that you have. So you have to define your sample size. So now we know the population size, but we didn't define our sample size. So let's say, for example, we need to have a sample of 11 people. All right? So our sample size is 11. You will be applying this equation over here to find out from each subgroup, from each stratum, how many samples should be taken so that we can get a total of 11 people from the entire population. Meaning, for 1, all right, so for ST1, we are going to apply this equation, which is stratum size, which is 10, over the entire population size, which is 40, times the sample size that we have defined, which is 11. All right? You're going to do this for each and every case. So for ST2, we're going to do the same thing again. 12 over 40 times 11. ST3, it is 8 over 40 times 11. And then ST4, we have 10 over 40 times 11. All right? And then we're going to, if we put all of these in the calculator, we're going to get values. Okay? So if I put 10 over 40, that's 1/4 of 11. That is roughly 2.75. Okay, we cannot have 2.75 of a person, so we have to always round up when we're talking about data when it comes to people. So when we're rounding up here, we're going to get 3 people. Same thing here, 12 divided by 40 times 11, we're going to get 3.33. When we are rounding here, we have to round down. We're just going to apply the normal rounding method. So because this is less than 5, so we're going to be rounding, right? So this is less than 5, so we're going to do nothing here. We're going to have 3 again. Okay, same thing here. We're going to get 2.22, which is equal to, or rounded down, it's going to be 2. And here we're going to get 2.75 again, which is 11. Sorry, not 11, 3. Okay, 3. So what are these values? These values now that we have found here, this is our sample size from each stratum. So from the first subgroup or the first stratum, the people in green over here, we are going to select 3 people from them. So if I just copy paste this down here one more time. Oh, it's already done here. All right, so this is what this means. So if you notice, we got 3 over here from the first subgroup. So there's 1, 2, 3 from the first subgroup. The second one, we also got 3 again. So there is another 1, 2, 3 from the other subgroup. The third subgroup or stratum, we got 2 only. So 1, 2 have been selected from the third stratum. And the last one, we got 3. So 1, 2, and 3 have been selected. And if you add up all these numbers, you're going to get your sample size that you wanted from the beginning, which is equal to 11 sample size. All right. And that will be your population or your sample size that you're going to be taking the data from. Okay. This is basically it. When it comes to any question like that asks you for, I only, the questions I've mainly seen was about stratified random sampling. They're going to give you a question that is going to tell you there are, for example, 3 categories. Okay. And you're going to have, and they're going to tell you one of them is management, where you have 10 people there. 2 of them is, second one is technical, for example, and you have 20 people there. And the third one is admin, and you have 20 people there. All right. So the question is saying, using a stratified sampling, how many from each category should be included in a sample of 5? So our sample size is given to be 5. So first things first, this is our stratums. So this is stratum 1. This is stratum 2. And this is stratum 3. All right. So we have our 3 stratums. Our population, you're going to have to add 10 plus 20 plus 20. We have to add all the subgroups to get your full population. So it's going to be equal to 50. And this is our population. All right. And then we just apply the equation again. And we just, for each stratum, and we'll be able to find our sample from each specific subgroup. So how do we do that? Remember, the equation is stratum size, the size of your stratum, divided by the total population size times the sample size that you need. So in this case, our stratum here is 10. Population is 50. Sample size is 5. And we're going to get 10 over 50 times 5, which is 1. Same thing again here, 20 over 50 times 5. We're going to get 2. 20 over 50 times 5, we're going to get 2 again. If you notice here, so we're going to get 1 from the management, 2 from technical, and 2 people from admin as our sample size for, if you add them up, you're going to get your sample size of 5 people. And this is it for any type of question you might get. This is how you're going to be just applying this equation, and you'll be able to solve. Is there any questions about sampling and sample size so far? So I can move on to frequencies. All right. Let us talk about, so now we talked about data and the collection of data and the types of data and all of that and how to get the sample. So now we know how to collect all the data we want from the people. All right. Well, no matter what the data is, we know how to collect it. We know the types of it. We know how to source for it. Now let's talk about presenting this data. All right. So data presentation. So now that we have gotten all this data, we need to look at it, like we have to present it in a way so that we know how we can analyze all this data. All right. So let's take a simple example from the beginning. Let's take an example of this. So let's say you did a survey or whatever, and you got these as your answers. For example, what is your favorite pet? All right. And you got these as your answers. You got bird, fish, cat, cat, rabbit, hamster, gerbil, cat, rabbit, rabbit, fish. All right. So you got a number of different, this is obviously qualitative information. These are not numeric, this is qualitative. And you want to put it in a way that you can explain it or you can analyze it further. So the best way to do this, there is one of 2 ways to do data presentation. The first one is tabular, as in making a table. All right. And the second one is graphical. Okay, which is basically plotting, like making a table, a graph or a plot or of some sort, so that you can look at it in a better way. So let's look at this from a tabular point of view. So from a table. So let's build a table. When it comes to information, when it comes to data that you're gathering, all right, you're always going to have 2 main categories on your table. This is always going to be the case. You're going to have the data itself, all right, So let's do it this way. So you're going to have the data here itself, whatever you gathered, the animal in this case. So let's say pet, for example. And then you're going to have something called the frequency. What does this mean? Frequency. What does this word mean? Frequency means how often. يعني كم العدد، كم مرة صار هالشيء، يعني كم مرة تكرر هذه الشيء. This is what frequency means. In other words, let's look at this sample as an example. So let's look at cats first. All right. So let's look at the cat. So that is our first animal or pet. So we have here cat. This is 1. This is 2. This is 3. This is 4. We have 4 cats, 4 people that chose cat, I should say, as their favorite pet or whatever, or animal, or and yeah, and so on and so forth. So this is what frequency means. يعني كم مرة هذا متكرر? How many times the people have chosen this? Same thing we can do for the next one. Let's look at bird, for example. Bird. Only one person from this sample size has chosen bird. So we were going to put 1. Let's do the same thing with fish. We have fish, fish. So 2, fish. Okay. Same thing we're going to do with hamster. We have hamster, only 1. So hamster, only 1. Rabbit. We have 1, 2, 3 rabbits. So rabbit, 3. And then the last one is gerbil. There's only 1 gerbil. Okay. This is how you would build your frequency table in the case of singular data. By singular data, I mean that this data over here. It is, there is no range. It is qualitative. So ما عندكم range, ما عندكم measurement or anything. It is direct data. يعني عندكم بس cat. ما عندكم نص قطوة أو ربع قطوة or whatever. Okay, that's not possible. So this is known as singular type of data. Okay. This singular type of data can be either quantitative or qualitative, but because it is just one value, يعني you just have cat, you don't have a range of values, this is known as single value data. Okay. It can be, like I said, qualitative or quantitative. There is a different type of data, which is going to be a range of values, which we'll look at now. Let's look at these numbers. Okay. Let's look at these numbers. So let's say we are given this set of numbers over here. We have numbers starting all the way from number 1 all the way up to 20. Okay. So if we wanted to build a table, we could build a table where, like, we say this is our data, whatever the number means, and this is our frequency. Okay. But we're going to have to write 1, 2, 3, 4, 5, all the way till 20. This is going to be tedious. It's going to be very long. So when it comes to numerical data, it is much better to draw it to have a range of values, which is also known as class intervals. All right. And it's going to look something like this. Okay. So first you have here your data, whatever it is, whatever these values mean, it doesn't matter. All right. Data and your frequency. Okay. Actually, I am going to add one more block. Then I'll explain in a bit why. To make it easier to count your frequencies when you're putting it. It is not important 100%, but it makes it much easier when you have a large number of samples, like a large sample size. So a lot of data. All right. So the way you can do this is you can have a range of data. So instead of saying 1, 2, 3, 4, 5, you can say that this is from 1 till 4. And then you can say this is from 4 till 10. And then you can say that this is from 10 till 13. All right. And then you can say this is from 13 till 17. And then you can say that this is from 17 till 20. Okay, don't bother yourself with the ranges right now. These are just randomly, I am putting them down just to show as an example. Later, we're going to look at how you have to define your ranges, but I'm just using this as an example for now. So when we're saying 1 to 4, what is important to understand here is when you're writing a range this way, this basically means, let's say this is data for X, all right? So this basically means X is less than or equal to 1, less than 4. So this is not included in your table, okay? This is a very important point. Why is this the case? Because the next phase or the next step or the next part of the table, the next row, is including the number 4, but it will not include the number 10. So you cannot write 4 both up and down. So this is always going to be the meaning if you have a range. If you're starting from 1 to 4, 1 is going to be included, but the 4 is not going to be included. Okay, so this is what this basically means. So what is this tally that I have added here? This is basically now when we are trying to look at our frequency, let's look at the numbers that are between 1 and 4 and write them down. So we have the number 1 over here. You will just put a slash or a dash over here for the number 1. And then we're going to look for another number 1, nothing. Okay, let's look at for the number 2 over here. So you're going to put another slash. This is what a tally basically means. يعني عدد يعني قاعدين تعدونهم كيف بالخطوط تعدونهم. That's all you are doing. Then we're going to look for another number 2. We don't have it anywhere. We're going to look for number 3. We don't have any number 3. And that's it. We are not going to look for number 4. Number 4 will come in the next part. So if you notice here, we have 2 lines. So معناته this is 2 for the frequency for the range of 1 to 4. Now we're going to look at for the values from 4 to 10, including 4, but excluding 10 without the 10. So we don't have the number 4 here. We don't have the number 5 here. We don't have the number 6, but we have the number 7. We have the number 7 here again. So this is set for the 7s. 7, that's it. We have the number 8 over here. We have the number 9 over here. And then we have another number 9 over here. And this is how you complete a tally. You're going to put a slash after you do 4 numbers. This basically means that you have achieved 5. I'm pretty sure most of you know this, but just in case you haven't seen this before, when you do a slash like this basically means you have completed 5 numbers. All right. And then you're going to start all over again for the future numbers if there are any. So 7, 8, and 9, there's no more 9, and 10 is not included, okay? We do not include the 10 in this tally. So this is going to be 5. The frequency of it is going to be 5. Going on for the range from 10 to 13, this basically means 10 is included and 13 is not included, okay? So 10 is included, that's 1, 11, that's 2, 12 over here, that's 3, another 12 over here, that's 4, and that's it. 13 is not included, so we don't include it. So we have 4 values, or 4, the frequency of the range from 10 to 13 is 4. 13 to 17, let's go to that. 13 to 17 is including 13, so 13, that's 1. Any more 13s? Nope. 13, 14, that's 2. Any more 14s? Nope. 15 is included, so we have 1, 15 over here, another 15 over here, another 15 over here. We reached 5, so we cross it out. Another 15 over here, so we're going to put another slash next to it. Any more 15s? Nope, that's it. 16 is included. There's a 16 over here. Any more 16s? Nope, that's it. 17 is here, but it is not included in this range. So this basically means 5 plus 2, so it is 7. All right. And then the last one is going to be the remaining numbers, obviously, from 17 all the way to 20. What I should have actually written here was 21. All right. Because remember, this is going to be 17 less than or equal to x less than 21. So if there is a value of 20, I'm not going to be able to put it in here, but I'm going to show you how to define a range in a bit. Don't get confused by that now. And now we're just going to apply the same exact idea. So 17, there's 1, 18, there's 2, 19, that's 3, 19, that's 4, 19, that's 5, and 20, that's 6. And this is our frequency table for this data range. This is obviously in tabular form. We can also put it in a graph form, which I will talk about later on. But this is how you would be taking any form of data, whether it was qualitative or quantitative. In the case of qualitative, you don't do any ranges. You're just going to put the actual single type of data. So a cat or hamster or bird, and then you're going to put the frequency. When you're talking about quantitative, you have numbers. You can put a range, all right? And I'll show you how to define that range in a bit. And then you're going to tally, so you can count if you have a large sample space. This is not usually necessary when it's small sizes, but it's easier to keep count so you don't get lost while counting. And then you're going to put your actual frequency after that. Okay? Any questions so far about this? Again, it is very important to note these inequalities over here. Your range is always going to be, let's say, from 0, inclusive to x, exclusive of, let's say, 10, for example, all right? This basically means the range from 0 till 10 in a table, okay? Keep that in mind. So make sure that this is understood very well when you're doing data ranges. I recommend when building a data table, write it in this form inside the data part, all right? Whether it was height, weight, age, it doesn't matter what type of data. Just make sure you write it in this form so you don't get confused and you understand how you should be doing all of this. All right. Let's do one more quick example about this using this value over here. So here the table was already given. Again, table was already given. And we have values here with decimal points. But again, we are going to apply the same exact idea. So we're starting from 30 all the way up to 40, but not including 40 itself. All right. So you're going to take values that are up to 40, but are not including the number 40 itself. Tamam? So how are we going to do that? Just a second. So how are we going to do that? We're going to look at any value that is larger than 30 but less than 40, including 30 itself. So here we have 32.3, that's 1. We go in order. This is 40, but we are not including the 40 in the first one because it's not including it, all right? Because it's less than but not equal to. Then we have 31.8 here. Then we have 39.6 here. Then we have 38.7 here. Then we have 30.6 here. So we cross it out. Then we have 34.8 here. And that is 5 plus 1, which is 6 for the first frequency. Same thing again. Now 40 is included, but 50 is not. So we're looking at numbers between 40 and 50. So here we have 40, that's 1. 42.3, that's 2. 47.1, that's 3. 45.2, that's 4. 48.1, that's 5, so we cross it out. 43.1, that's 6, and 41.2, that is 7. All right, same thing we're going to do for the 50 now, including 50, but not including 60. So 51.5 is between them, that's 1. 51.2 is between them, that's 2. 60 is not in between them because it's not including 60. 53.2 is, and 55.8 is, so this is 4. Next one, from 60 to 70, we have 62.1, that's 1. 72.9, that's not. 60 is included now, so that's 2. And that's it, we have 2. And lastly, we have just 72.9, which is 1, 1. And you have now built your frequency table. All right? And this is very simple, very straightforward when you're given the height or when you're given the range. But what if you're not given the range and you have to do the range for yourself? So let's take a look at this example. So I want to build the frequency table for these values, all right? Given these values, I need to identify the range myself. So how can I do that all by myself? The way to do that is, first, you need to know a few things. We first need to, step 1, you need to identify the range. range is equal to upper limit, or I should say actually the maximum limit, the maximum minus the minimum. All right, this is what the range is. So we're going to have to look at the largest number that we have here. What is the largest number that we have here? It is 130. This is our maximum. And what is our minimum number? What is the smallest number we have here? Let's see, 67. Is there anything smaller than that? Nope. So this is our minimum. So now our range is equal to the maximum, which is 130 minus 67. We get 63. All right. This is our very first step. This is known as the range, and these are known as our maximum and minimum values. All right. The second step is we need to identify how many classes we want. What does that mean? You notice here, this is what they call a class. All right. So this part over here, let me actually highlight it. This is known as a class. Okay. So here we have 1, 2, 3, 4, 5. We have 5 classes. Okay, this is what they just call a class, right? The first column, they call them classes. So we need to identify now how many classes we want. This usually, the standard is step 2. Class width, and I'll talk about that in a bit. But the standard number of classes is usually given as 5. Or sometimes it will be just given in the question, depending on the question, or if it's not given, you can assume a number of 5 just to make it easy for yourself so that you don't have too many rows. This is usually what is gone for it. So we have identified the number of classes. But I was talking about class width. Class width is the range that, or the limit in between where your x value is going to be. All right. So class width, this basically means if you have x less than equal, a number here, I'll call this A1 and A2. All right. Or actually, a better way of calling this is going to be LL and UL, where this is known as the lower limit, and this is known as the upper limit. Okay. This is not going to be equal to, this is just less than over here. All right. So this is what the class width is. So we need to find the class width. How do we do that? So now that we have found our range early on in step 1, the class width, CW, is going to be equal to the range that we found from step 1 divided by the number of classes that we need to find. That easy. All right. So the class width in this case is going to be equal to 63, which is our range, divided by 5, which is our number of classes. All right, this is what they call the class width. If we put that into the calculator, we're going to get a value of 12.6. Now, this is a very important thing over here. This we will always round up. Okay, it is not really a big deal in general, but you should always round it up. You should never round down, no matter what. Even if it was 12.1, you're always rounding up this value. Always round up. So it's going to be equal to the class width. It's going to be equal to 13. All right. So this is our class width. We have determined that the class width is equal to 13. Remember, the class width is how much range we have between the lower and upper limit in here. Okay. Now, the last step, step 3, the last step that we do here is going to be choosing our actual lower and upper limit. So to start with, we first have to define our minimum. So what is our minimum? Our minimum is equal to, we have to have a starting point. So this is our minimum, which is 67. All right. So the lower, this is also the minimum or the lower boundary. All right. This is going to be where we are going to start our first point from. All right. This is going to be our first lower limit or lower boundary. All right, so we're going to say that this is 67 is less than or equal to x. This is our very first number because this is the minimum. This is the very first number or the smallest number we have in our sample. And then we're going to add here plus 13 to 67. All right, this is what our class width. This 13 here is just our class width. So we're going to get a range of 67. 67 plus 13 is equal to 80. And this is going to be our very first row, right? So the first thing you do is you get your minimum. Then the second thing you do, add class width to minimum, all right? Which is this step over here, okay? So you're going to add your class width to the minimum. And then that is going to be your very first line, all right? And this is where your frequencies are going to be later on. Okay, so this is data, and this is frequency. This is for the first one. What about the second one? The second one, the starting point is going to be the end point here. This is going to be your starting point here, which is 80, less than or equal to. And then again, you are going to add 80 with 13 to get your next upper boundary or upper limit. All right. So it's going to be from 80 all the way to 93. Remember, it's only less than, not equal to. And this is going to be your second line. And you're going to keep repeating the same process for each and every step. So this is going to be 93 plus 13, which is 106. All right. Let me make this a bit smaller so you guys know that the actual value is 106 and 93. All right. So 93 plus this 13 gives you 106. Again, this is our third class. Our fourth class is 106 less than or equal to x less than 106 plus 13. So it's going to be 119 over here. And remember, we're going to have 5 classes depending on the question or depending on our assumption. We wanted to have a number of 5 classes. So we know that here we should be already reaching the upper limit or more than the upper limit or more than the maximum, which we are going to look at now. So it's going to be 119 less than or equal to x less than 1. So 119 plus 13, which is 132. All right. A very important thing to notice here is, if you remember, our maximum is 130, right? So our max was 130. This has to be larger than max. This is why we are rounding up always over here, so that we always get a value that will be larger than our max value for the very end. Technically, based on this data set, you can put any large number here, technically, any number larger than the maximum value. But because we want equal sized classes, we're going to start from the minimum, all right? So again, this is our minimum value. This is our minimum value. All right, and this is larger than our maximum value, where our max value is 130. And this is how you will build your actual classes for each and every step. And now, so we have this table, all right? If I want to just make it a little bit smaller, let me copy paste this down here. Make it a bit smaller. This is now our table, okay? So we have already defined our table. We have defined our ranges. We know that this is the data and this is our frequency over here. Okay, we can actually put on all the values of the frequency now. Same method we usually do with the tally and all of that, so that we can find all the frequencies of all the numbers. All right, so I'm going to write frequency here again. I'm going to write this is frequency and this is our tally. Okay, this just makes it easier for counting. So we're going to apply the same concept now. So from 67 to 80, including 67, but not including 80. So we're going to go step by step. This is 70, which is included. 80 is not included. 70 is included. 80 9, no, 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 70 is included. So obviously you're going to be tallying up. So 1, 1, 1, another 70, that's another one. 67, that is included, that's 1. These are not included. 78 is included. Sorry, this is the one not like that. So again, once you reach 5, you're going to be doing 1, 2, 3, 4. Your 5 is going to look like that. And then you're going to add another 1. So we have 1, 2, 3, 4, 5, 6 so far. And then we have the 76 over here, 7. So this frequency is going to be 7. All right. Same thing again now. 80 is included, but 93 is not included. All the numbers in between. So no, 80 is now included. 1. 90 is included. That's another one. 85 is included. That's 1. 84 is included. That's 1. 98 is not. 88 is included. So we're going to do 5 over here. 90 is included, that's 1. 82 is included, that's another one. 94 is not included, sorry, this is greater than 93. And 80 here is included, that's another one. And 88 is included, that's another one. So we have 5 plus 4, which is 9. This is our frequency for this one. Same thing again. Now 93 is included, 106 is not included. So 105 is between those values, 100 is between those values, 98 is between those values, 102 is between those values, 94 is between those values, so we cross it out. 110 is not, 130 is not, but 95 is. So we have 7, sorry, 6. 1 second. 1, 2, 3, 4, 5, 6. Is that it? Yeah, 6. Oh, I forgot the 95 over here as well. That's 7. Okay. So that's 7. So 1, 2, 3, 4, 5, 6, 7. All right. And now, again, for the next one, 106 and 119, there's only 2 values left. This is between them. The other one is not. So we have 1. So this is just going to be 1. And the last one is 130, which is 1 and 1. And this is how you would build the frequency table in the case of um, when you want to define the range or define the class width by yourself. All right. So this is what they call the class width. The range from 67 to 80, that's the class width. So technically our class width is equal to 80 minus 67, which is 13. All right. I know we defined it in this case, we already defined it by ourselves using this equation, which is the range divided by the number of classes, and we rounded up. But when you are already given a data set, you can find your class width by subtracting the top value with the bottom value directly. All right. And in this case, since they are all equally sized, they're all going to be equal to 13. This is known as our class width. And we wanted 5 classes. So we have 1, 2, 3, 4, 5. We have our 5 classes over here. Any questions about this? Is this clear? All right. Let us take a short break. All right. And then we will continue and look at the graphical way of analyzing all of this. Let's take a break until 5:20. All right, we'll be back at 5:20 p.m. If you have any questions for now, feel free to ask in the chat. And we'll be back at 5:20 and we'll continue the graphical method. All right. So we looked at the way we usually do tabular data, how to do it in a table. Now we're looking at the graphical method. So there are multiple different graphs that you can be using to plot data, right? First one we're looking at here is the line graph or the line chart, all right? The line graph is simply, you can notice that you're going to have specific singular data over here, such as Monday, Wednesday, Tuesday, the days of the week in this case, and the number of, in this case, pizzas that are being sold. So this basically means, if you notice here, this is 10. On Saturday, 10 pizzas are being sold. On Sunday, there is a number of 30 pizzas being sold. Same thing for Monday. On Wednesday, it's 50. And on Thursday, it is 70. All right. So if you get a question where you have to plot something like that, you will do the exact same thing. So the first part is the year, all right? And then there's the population. Your population will be on the y-axis. And so this is going to be your population in millions. And you're going to have the years down here, all right? So you're going to say this is, for example, 2000. This is 2005. This is 2010. This is 2015. And this is 2020. And then you're just going to plot the points. So we can see that the range here starts from 0.7 and goes all the way up to 1.5. So let's say that this is 0.2. Now let's start with 0.5. Actually, let's do 0.25. Okay. So let's say that this is 0.25. This is going to be 0.5, 0.75, 0.1, then 1.25, and 1.5 over here. All right. So obviously you have to choose a proper scale that includes all the range of values starting from the lowest value, in this case 0.7, all the way up to the maximum value, which is 1.5. And then you just start plotting and marking the points on the graph. So in the year 2000, we had 0.7. So 0.7 is roughly somewhere around here. Okay. And this is for the 2000. So this is going to be our first mark. For 2005, there was 0.9. 0.9 is almost close to 1. So it's going to be marking over here. For 2010, there was about 1.2, so somewhere around here. 1.2. 1.4, that's closer to 1.5 for 2005, so somewhere here. And for 2020, you're going to have that. And then you're going to be drawing a straight line between each 2 points. All right, so it's going to be a straight line between each of the points. And this is what a line graph would look like when it comes to plotting. Okay, very simple, very basic, very straightforward. It's usually for singular data, and you can plot it very easily by just looking at the number and the year that it is, and marking your year in the, or the day or whatever, in your x-axis, and the population or the value in the y-axis. All right. The second type of graph you're going to see a lot is a bar chart. So a bar chart is simply, as the name says, it has bars in it. All right. So what does that mean? So if we look at this example here, we have the months given down here. So in January, we have 1 day of rain. All right. So this is in January. There's 1 day of rain. In February, there are 3 days where it rains. In March, there are 7 days where it rains, and in April, there is about 1.5 days where it rains, 1.5, which is an estimate basically. All right. So this is how you would read a bar chart. How about constructing a bar chart? Again, it's very simple to a line chart, but the shape is going to be just slightly different because now you're dealing with bars instead of a line. So the first thing you should notice in bar charts, there's going to be spacing in between them. Right? These are equally spaced from each other. They're not going to be connected to each other in a bar chart. So the first thing we're going to notice here is the car color. This is going to be our x-axis, our car color. All right, let me take this a bit up. So this is our car color, and on the y-axis is going to be our frequency. This is always the case. Frequency is always going to be on our y-axis in almost any type of graph. All right. So then you're going to mention the car colors down here. So we're going to say that this is white, and then we're going to say that this is black, and this is red. This is blue. I'm going to need more space. Let me just extend this line a bit more. All right. After blue, we have gray. And then we have other. So any other color. All right. And the frequency, again, you're going to see your lowest value all the way up to your largest value. So we start from 6 and our largest value is 15. So let's do it every 2, for example. So let's say this is 2, 4, 6, 8, 10, 12, 14, 16, and that's basically it on our y-axis. And again, you're going to just draw a bar all the way up to the point that you have. So for example, for white, all right, the frequency is 12. So it's at this point. So you're going to be drawing a bar like this for white. For black, it's at 15. 15 is somewhere in the middle over here. So this is going to be for black. All right. For red, it is 6. So you're going to look at the number 6, which is here. So it is going to be up to the 6 point over here. And this is your red. For blue, it is 10. You're going to go to your 10 value. Your 10 values here for frequency. And this is going to be 10. I mean for blue. And then for gray, it is 7. It's between 6 and 8. So it's roughly somewhere around here. Okay. This is your gray. And others is 8, which is over here. So this is how you will draw your bar graph. Okay, very simple. Make sure you know that your frequency is on the y-axis and the property or the data, whatever it is, qualitative or quantitative, it is going to be on your y-axis. And keep in mind, this is for singular type of data. These are all singular types. It's not a range. All right, bar charts are not going to be used for a range of data. It is going to be used for singular data. It could be used for range, but it is rarely used for it. That we will look at later, which is used in a histogram. And the most important thing in a bar graph is all of the width is the same width. The only difference is the height. The height is what will define our frequency for each one in a bar graph. All right. Now looking at a histogram. So for a histogram, this is a very important thing when it comes to frequency. For something, when you have frequencies, this is not the same as a bar graph. You're going to be using a histogram. The first difference between this and a bar graph, there is no spacing. All the values you have are going to be stuck together. And what this basically means is, if they are equal, this is basically your interval. All right. So this is basically x less than equal 5 less than 10. This is it over here. And the value for it over here. Just 1 second. Sorry about that. So as I was saying, this is the interval, and the value of the frequency will be here if this is the actual frequency in this case, which is the number of students. This only happens when you have equal widths. All right. So when you have equal widths here, this will be frequency. Okay. So that's the only time this occurs, that this is the frequency when they are in equal widths. If they are not equal widths, let's say, for example, if you have something like this, where you have something that is a bit more thicker, and then something smaller, and then something more thicker, and then something a bit smaller, and then something a bit more smaller, and then something, let's say, that is thicker again, something like that. Again, remember there's no spacing. Here you're going to have something called frequency density, and I will explain that in a bit when solving the example. And then here you will have your data, whatever your data is. All right. Here, what you need to know is the differences. So here, if we wanted to find the frequency for the interval from 5 to 10, it is simply just 5. All right. Or sorry, not 5. This isn't 5. This is, if this is 2, this is 3, this is 3.5. So the frequency here is equal to 3.5. All right. But in this case, the frequency will be the area under the graph. Here, frequency, this is a very important point, frequency is going to be equal to the area under the graph. So for example, let's say that this is from 0 till 5, and this is 6, all right? If you want to find 0 less than or equal to x less than 5, the frequency of it, you're gonna have to take the area of this square over here. All right, this is going to be your frequency. What does that mean? This means that this, if you look at it, this height over here from here, this is 6, and from here to here, this is 5. So the frequency is 6 times 5, in this case equal to 30. All right, and this is going to be clearer now when I solve the example. But this is a very important thing to notice. This occurs when your width is not the same, because this basically means that your intervals are not the same intervals, which if you remember from here, your class width here, we had the same intervals. They were all 13. But what if your class width was not the same for each one? What if the values, numbers were changing? What if this wasn't from 67 to 80? This is where you will have to consider frequency density. All right. And what is frequency density? I'll show you in this example now. So what do we mean by frequency density? So frequency density is simply the frequency divided by the width of the class. So if the frequency that we have for that value divided by the width of the class, or class width that we called earlier, CW, this is going to be your frequency density, which is also the height in your histogram. All right, this is what your frequency density is. It's going to be clearer now when we solve this question. So this question says, a table is given, all right? Use the above information in the table to draw a histogram. And it also mentions that, note that here the class width are not the same. Because if you notice here, the class width here is from 0 to 10, which is 10 minus 0, which is equal to 0, equal to 10, sorry. And here it is 15 minus 10, which is 5. So you have different class width. So class width 1 is not equal to, let's class width 1 is not equal to class width 2. They're different values. So what do you do here? First step, and before even drawing your histogram, is you're going to extend your table over here. All right. Going to extend it in this way. And you're going to add 2 more columns. The first column is going to be your class width, which I just showed you how to find your class width. All right. Remember, class width is simply just the subtraction of the upper minus the lower. So it's 10 minus 0 for the first one, which is equal to 10. 15 minus 10 for the second one, which is equal to 5. 20 minus 15, which is 5. 30 minus 20, which is 10. And 50 minus 30, which is 20. You're just taking this value minus this value. All right, you're just subtracting these two values. This is the first step, finding your class width. The second one is finding your frequency density. And what did we say the equation was? It is frequency, the actual frequency divided by your class width. So you're going to be taking this number, you're going to divide this number. That is how you find it. So it's going to be 5 over 10, which is equal to 0.5. And the second one is 15 divided by 5, which is equal to 3. The next one is going to be 10 divided by 5, which is equal to 2. The next one is 23 divided by 10, which is 2.3. And the last one is 12 divided by 20, which is equal to 0.6. All right? This is your very first step. If you have, this is in the case when the class width is not the same. This is how you'd have to build your, let me make it a bit smaller, just a bit. All right. So this is how you will build your graph using your histogram using the case of having unequal class widths. Okay. So now if you want to draw it, what we will be plotting is, actually move this line a bit higher. All right. What you're going to be drawing is the frequency density instead of frequency on your y-axis. So now here, this is frequency density. And here, this is going to be your classes. All right, your classes, which is from 0 to 10, 10 to 15. So we have our classes starting from the minimum value, which is 0, and our maximum value, which is 50. This is our maximum. So we're going to put values from 0 all the way to 50. Let's say this is 0. This is 10. Actually, let's make it a bit bigger, a bit wider, so it's clearer. So this is 10. This is 20. This is 30. This is 40. Nope, not this one. This is 40. And this is 50. Okay, from our minimum all the way to our maximum. Okay, this is our age in years in this example. The age, the data. On our y-axis now, we're going to be putting our frequency density. Frequency density is starting from 0.5 being our lowest and our largest value being 3. So I'm going to just put 0.5, 1, 1.5, 2, 2.5, and 3. All right? And now you can draw your histogram depending on each class width and frequency density. So for example, for this one, it's from 0 to 10. So you know you're going to be going all the way up to 10. From 0 all the way to 10. And the value you're going to be plotting is the frequency density. So it's 0.5. So you're going up to 0.5. And you're stopping here at 10. All right? So this is for the first one. The second one is from 10 to 15. So it's not going all the way to 20, it's going all the way only to 15. And what is the value for it? It's 3. So this is going to go all the way up to 3. And then coming back down at 15. Okay? The next one is 2, and the range is from 15 to 20. So it's from 15 to 20 over here. The next one is 2.3. So 2.3 is somewhere in the middle over here. So it is going to go up to 2.3, and the range is from 20 to 30. So it's all the way till 30. So it's going to be like this, going down to 30. And then the last one is a full range from 30 all the way to the maximum value of 50. And the value of it is only 0.6. So it's somewhere roughly here, from 30 all the way to 50. And this is how you would draw a histogram in the case when your class width is not equal for your different values. All right. The second part of this question says, estimate the number of people who watched the movie within the age range of 25 to 45. So what does that mean? We are looking at people between the ages of 25 to 45. So what do we do here? Here we have to mark at the bottom in our x-axis where the ages 25 start and where it ends, which is at 45. So 25 is somewhere here. All right, this is 25. And where's 45? It's in the middle over here. So what you will do is you will follow this path. So you're going to draw a vertical line up to where it is, where the line is, where the horizontal line of the frequency density is, and you will close out the blocks in this manner. All right. So if you notice now, we need to find the frequency. What did I say the frequency was in this case? The frequency is going to be the area under this graph. So this entire area. And if you remember from Math 1, it is very easy to find the area of two simple shapes. So let's say, for example, we want to close it off at here, right? And call this our area 1, and this is our area 2. Let us find the dimensions. So area 1 is length times width. What is our length? This is going from 25 all the way to 30, so this is a size of 5. So this is 5. And the height of it is up to this point over here, which was 2.3. All right. So this dimension is 2.3. So it's 5 times 2.3. This is our first area, which is going to be 5 times 2.3 gives us 11.5. The second area now, similar idea. We're going to go and find the height and the width. So the width is from 30 to 45. To find that, you just do 45 minus 30, which is equal to 15. That's the width of this shape, of this rectangle, I should say. And the height of it, it goes all the way to over here, which is 0.6. All right, because remember, it goes to 0.6. So it's going to be equal to 15 times 0.6, which is equal to 9. Now we do 1 plus 2, area 1 plus area 2, which is 11.5 plus 9. And this is going to give us 11.5 plus 9. This is going to give us 20.5. Obviously, when we're talking about frequency, we don't have any decimal points. So here, usually, what you can do is either round up or down depending on your decimal. So in this case, we have 5. It's greater than or equal to 5. That's what, then we're going to have to do plus 1. So our frequency is going to be equal to 21 people, roughly. Or the age of 21 people. Actually, yeah, the frequency is 21 people of the age between 25 and 45. Why is this? Why do we get a value in decimal points? Because we do not actually know how many people are in the age 25 exactly. We know the range is only from 15 to 20, 20 to 30, and 30 to 35. We don't have these specific ranges identified. So we don't have the exact data of those specific people. That's why you're going to get a rough estimate. Even in the question, it says estimate the number. All right. And this is how you would find the frequency using a histogram. Okay. The next graphical method is a frequency polygon. All right. So if we look at this real quick, a frequency polygon is basically, all right, it's basically just taking the midpoint of all our intervals. For example, in this case, these intervals, it takes the midpoint of it and it plots it on the graph depending on the frequency you have. Simply put, all right, if we look at this example over here, we are going to put an extra bar block over here, and we're just going to name it the midpoint. What is the midpoint? You're going to be adding the upper limit with the lower limit and divide by 2. So this is going to give us 5. So this is our first midpoint, which is 5. All right. For the second one, so this was for the first case. For the second case, it's going to be 10 plus 20 divided by 2, which is equal to 15. So our second point is 15. All right. Same thing again here. We have 20 plus 30 divided by 2. That's how you find your midpoint. All right. This is the equation for midpoint. You're going to take your upper limit plus the lower limit and divide by 2. This is going to give us 20 plus 30 is 50, divided by 2 is 25. And last one, 30 plus 40 divided by 2, 35 over here. Okay? So this is your very first step. You're going to find the midpoint of each interval. Then you just plot it. But there is an extra step when it comes to the plotting. All right? So again, remember, we always have our frequency over here on the y-axis, and in this case, we're talking about length. So this is going to be our length. All right. Now we are going to put points for our midpoint at the length of the axis. So we're going to start from 0 here. Let's put 5, and then 10, 15, 25, and 35. And you're always going to take an extra point over here. So this we're going to take as 45, and an extra point before this, which in this case, unfortunately, it's in the minus region, which is going to be minus 5. And what is the value of this point? Remember, if you look at here, the differences, this is increasing by 10. So you're going to go 10 steps behind, which is minus 5, and you're going to go 10 steps ahead in this case, which is going to give you 45. All right? These 2 points are going to be your starting points. All right, your 0 points. So you're going to have a point over here and a point over here. And then you're just going to plot the frequencies. So we have 2, 4, 6, and 8. All right. 2, 4, 6, and 8. So this is 2, 4, 6, 8 over here. From 0 to 10, the midpoint is what? 5. 5, what is the value of it? It's 6. So we're going to put a marking here at 6 and 5. Same thing here, 15, the point is 8. So from 15, it is 8. 25, it is at 4. 25, it is at 4. And then 35, it is at 2. So 35 is at 2. And then you're going to draw a straight line between all of these points. And you will connect it to the points at the very end over here. This is 45, and the first point you'll connect it to here, which is at the minus 5. Realistically, it should start from this part, from the positive axis, because you don't have negative length. But this is just the concept of it, how you have to plot the graph. All right. And that's what a frequency polygon is. Now, the last one, which is the most important graph, it is the cumulative frequency graph. All right. So the cumulative frequency graph. The cumulative frequency graph is always going to be in this shape where it's always increasing, all right? It's always going to be going up, and it will always start from a point of 0, all right? How do you look at this graph? Like, what is the meaning of this graph? Let us explain it using this example, okay? So before even thinking about plotting it, let's look at what is meant by cumulative frequency, okay? So you already understand this, the number of hours and all of that. And in this case, if you notice, they put the less than first and then the less than and equal to after. It doesn't matter much, but it is preferred to start with less than or equal to. But here they defined it initially in this way. Okay. So since they defined it in this way, we're going to just follow the steps that they are doing, or the definition that they are doing from their side. Okay. Now, the first step here is to determine our cumulative frequency. What does this mean? Cumulative frequency means it's as if we are adding all the frequencies and moving forward as we add, meaning that we are looking at the range from 0 less than h less than equal to 2 for the first one, all right? So it is 20. The starting point is always going to be the same as the actual frequency, okay? So this is 20. The next one, we are not looking from 2 to 4. We are looking from 0 all the way to 4. This is what is meant by cumulative frequency. So for the next one, we are going to do 20 plus 32, because we are looking at this entire part. So 20 plus 32, which is going to give us 52. The same thing again for the next part. So this is for here, and this is for here. So the next part over here, we are looking at from 0 all the way to 6. This is what is meant by cumulative frequency. You're looking at the frequency at that point, starting from the very initial point, from the minimum that we have given. All right. So again, now we're going to be taking this entire part, or in other words, we can simply just say 52, the cumulative of the previous one, plus 48, which is the frequency over here. And this is going to give us 100. Again, the same thing for the rest. So this is from 0 all the way to H8. 100, which is the cumulative frequency we found earlier, plus 120, which is 220. The same thing again here. This is from 0 all the way to 10. And the last one is from 0 all the way to 12. Again, 220 plus 24, which is 244. And the last one, 244 plus 16, which is equal to 260. All right. So the idea here is we are taking the cumulative frequency and we are adding it with the 32. All right. That's what we are doing. The same thing for the next step. We're taking the cumulative frequency and we are adding it to the actual frequency. All right. This is what is happening here. Okay. And here, this is what is happening. Same thing for the next step. We are taking the 100 and the 120 and we are adding them together. Same thing for the step after that. We are taking the 220 and the 24 and we are adding them. All right. Last step, very exact same thing. We're taking this and we are adding them. We get our cumulative frequencies. So now that we have our cumulative frequencies, let's actually plot these values in a cumulative frequency graph. All right. Let me copy paste this down here and make it smaller a bit. So this is the table that we have, and this was the given table, for example, to draw on. So the first value is going to be from 0. Sorry, just one second. All right. So the very first value, again, look, if you notice here, this says cumulative frequency. All right. This is cumulative frequency. This is where we are going to be plotting our frequency. The first range we have is going from 0 to 2, right? So since we are going from 0 to 2, we are going to get 20. So we go to the point 20 over here from 0 to 2. This is going to be our first point on our graph. All right. And then from 0 all the way to 4. Now we're looking at 4. We're going to get 52. So this is the 52 mark roughly over here. Is that right? No, it's a bit lower. That's 60. So it's a bit lower. It's going to be 20, 40, 60. So 52 is going to be somewhere about here. Same thing. And you're going to keep on plotting. Now for the 6, from 0 to 6, it is 100. All right. Just so I can make this a bit more clear. This is the green dot over here. This is the green cumulative frequency we found. This is the purple one we found, the 52 over here at 4. The next one is the orange dot, which is 100, which is over here, and this is going to be at 6. The next one is 220, which is our blue dot, and that's going to be at 8. So 220 is in the middle over here. The next one after that is 244, which is the brown dot over here. At 10, 244 is somewhere about here. And the last one is 260 for 12. And then you are just going to combine all these lines starting from 0 at 0 at 0. You're going to be combining all these dots together. All right. So this is how you would draw a cumulative frequency graph. Again, it is very important to know how to obtain your cumulative frequency values from the beginning so that the plotting of the graph can be much easier. Okay. Now, what if we have a question given about this graph? The questions that they might ask, I don't know if it was asked in this one, no. So I'm going to put down these questions. So the first question they're going to ask for is find the median from the graph. All right. Median, we're going to talk more and more about it, but I want to talk specifically when it comes to cumulative frequency graphs. The median is going to be basically the middle point of the data that we have, in this case, hours revising. So our maximum value, what is our maximum value? Our maximum is equal to 12. Just a second. So again, our maximum value is going to be 12. All right. At this maximum value, we had a frequency of 260, our cumulative frequency. And our minimum value is 0, which is 0 at the very beginning. All right. Actually, no, our minimum value is 20. Our minimum value at 0, it's going to be a cumulative frequency of 20. Okay, because that's the data that we have from 0 to 20. Okay. Sorry, just 1 second. I really need to take this phone call. I'm very sorry. Just 1 second. Sorry about that. So where was I? Yes, the median. Again, so we have our maximum is at 260. All right. This 260 is basically our total frequency, our cumulative frequency, which is the total frequency that we need to find. The median is going to be half of that frequency. So it's going to be 260 divided by 2, which is going to give us 130. All right. This is the median that we found for, this is how we can find the median actually, using the middle of the frequency point. So 130 is going to be roughly somewhere around here. And you're going to go all the way to the graph. And now you can find your actual median value for the numbers over here, which is roughly between 6 and 7. So you can say 6.5. So your median is going to be equal to 6.5 hours, because this is given in hours of revising. That's how you would find your median using the graph. So you're going to find your total, the half of your total frequency. That will be your middle point. You go to that on your y-axis, and then you're going to plug in, find out from the x-axis your your value for your median, in this case being 6.5. That is the first question that they might ask. The second question they might ask is something called the lower and upper quartiles. So LQ, which is lower quartile, and UQ, which is upper quartile. All right. The lower and upper quartile, all that means is this is 25% of the total, and this is 75% of the total. All right. So you're going to find out the 25% mark of your 260, and your upper quartile is going to be 75% of your 260, which is your total frequency. All right. So in other words, LQ is going to be equal to 0.25 because it's a percentage. So it's divided by 100 times 260, which is equal to 130. And your upper quartile is going to be 0.75 times 260, which is equal to 0.75 times 260, which is 195. This is not 130, this is 75, I believe. Let me double check my work. It's 65. All right. So this is our lower quartile and our upper quartile values from the frequency. So for the lower quartile, which I'm going to be doing in purple, all right, the lower quartile, we're going to go here to the value of 65. So earlier on, the median, we found it at the value of 130. This, we are going to go up to a value of 65, which is somewhere around here. And we're going to draw a line. And we are going to find the value here as our lower quartile, which is roughly equal to between 4 and 5, a bit more. So say 4.75, roughly. Same thing again for the upper quartile, which I'll do in red. It is at a frequency of 195, a cumulative frequency of 195. So going up to 195, which is almost next to 200 over here, 195, you're going to draw a line to your actual graph, and then you will draw a line downwards to here. It is somewhere around the 7.75 mark. This is your upper quartile, which is equal to roughly 7.75 hours of revising. And then the last part that they might ask you is to find the interquartile range. So this is interquartile range. What this basically means is it's just the upper quartile minus the lower quartile values that you find. That's all that is. So the upper quartile was 7.75 minus the lower quartile, which is 4.75. So it is going to be equal to 3. And this is your range. So 3 hours of revising. Okay. And that's pretty much it. That's how you would be able to analyze or look at a cumulative frequency graph and get the values from it. I was hoping I would be able to complete week 11 with you guys today as well, but did not happen. Inshallah, tomorrow I will start from 0 with week 11. And yes, I will be sending the notes. Don't worry about that. I will send it in this chat.